Hello and welcome to Tvaritam.AI. In this video, we are going to discuss feature selection. Feature selection is the process of identifying the most relevant features in a dataset to train our machine learning model. Instead of using every available variable, we select a subset of features that provide the maximum predictive information while avoiding redundancy and noise. So using a limited but meaningful set of features help in several ways. It can reduce the size and complexity of the dataset, which makes model training faster and predictions more efficient. It improves interpretability. If model relies on 5 meaningful features rather than 20, it becomes easier to understand how those features influence prediction. It reduces overfitting. When too many irrelevant features are present, the model may start learning noise rather than meaningful patterns. Removing unnecessary variables allows the model to generalize better. It reduces computational cost because fewer features require less memory and processing, and feature selection can also improve data collection efficiency. If analysis shows that only 10 out of 25 collected features meaningfully contribute to predictions, future data collection efforts can focus on those important features instead of wasting resources on ones that are less relevant for the prediction. Using correlation to select feature is a common thing that we use, and it is usually working with two type of variables. First is your input features and the target feature. So for correlation between input features and target feature, features that show a meaningful relationship with the target variable are generally considered important and should be considered for retention. Correlation between input features themselves. If two input features themselves are highly correlated, they may contain redundant information. So there is a possibility that we can remove either of them. For example, if you have a same feature with different units like height in centimeters and height in inches, then you are getting exactly same information in different scales. So one of them can be safely removed. Or if there is a feature interaction like height, weight and BMI. Now since BMI is calculated from height and weight, it has already captured the combined information. So if BMI alone is useful for prediction, for modeling objective, we can drop height and weight. However, correlation based feature selection has its own disadvantages and therefore should always be used alongside domain knowledge and model evaluation before removing any features. Some of these disadvantages are that correlation only measures linear relationship. It may fail to capture important non-linear interactions. It does not imply causation. So two variables may appear correlated without having a causal relationship. Third is that correlation can be sensitive to outliers, which may distort the observed relationship. Now, when it comes to correlation, there are visualization techniques that are used. Instead of immediately training the model to test for every feature combination, we can use visualization techniques to quickly explore relationship between the variables. And one of them is scatter plot. So scatter plot are used to analyze relationship between two continuous variables. Each point represents one observation in the dataset. For example, as you see in the graph, if we plot room square footage on the x-axis and room rate in US dollars on the y-axis, we may observe that larger rooms generally have higher prices. In this case, room square footage is the independent feature and maybe room rate is what we are trying to predict as our target. If the point forms an upward trend, it indicates a positive correlation as seen in the graph. If it points a downward trend, then it is a negative correlation. And if the points are randomly scattered, there may be little or no correlation. The closer the points lie to the straight line, the stronger the correlation is in the scatter plot. Now, second is small multiple bar plot. This is useful when analyzing relationship between two categorical features. So in these plots, we create multiple bar charts showing the distribution of one categorical variable across categories of another variable. The x-axis represents the independent categorical feature, as you can see, and y represents the frequency or count of observations. So typically the y-axis label is our count. Now if you see customer type and booking channel, so you can see customer type may include categories such as leisure, business, group travels, while booking channel might include direct website, online travel agencies or corporate contract, right? So if distribution looks similar across categories, it suggests that variable may be independent. If there is a different trend, different patterns, then the features are correlated. As you can see in here, the leisure group is more prone to the OTA, while if you see on the right hand side, the silver group is more prone to OTA. This is what you can notice in the small multiple bar plots. Now in the box plot, we try to analyze the relationship between a categorical feature and a continuous feature. For example, consider loyalty program tier gold, silver and platinum as the categorical variable and the room rate or the annual spending as the continuous variable. Now distribution of room rate across the tiers looks similar. The loyalty tier may not strongly influence the price that you are getting, maybe a lesser price, but if you see in the right side of in the right graph annual spending, then platinum users are spending a lot more money in total. That can also mean that there are more platinum users. So you should always do an in-depth analysis before dropping any kind of feature. But this gives you some idea about how the features are correlated and how you can use them to understand which features are more important and which features can be less important. Now, what you see in the box plot, the center line, it is the median of the distributions. Now, summary of this is that you have to start with the domain knowledge to identify which features are likely to influence the prediction. So you can ask the domain expert or use your own knowledge to get some insights. Then correlation analysis can help you understand relationship between input features and the target variable. You should use appropriate visualization techniques. So scatter plot for continuous variables, small multiple bar plots for categorical variables, and box plot for mixed categorical and continuous relationship. You have to identify redundant features that are strongly correlated with each other. You can verify this with the domain expertise, all the findings that you get, and you can finally test model performance with and without certain features to confirm whether removing them actually improves the performance or keeps the accuracy similar or decreases the predictive accuracy. Checking for interactions is very important. You should not quickly drop the features, and checking the interactions could mean that maybe GDP, for example, is something that gives you an idea about the human development index. Similarly is the population, but GDP per capita can give you a stronger idea. So if you create a feature interaction using GDP and population as GDP per capita, you may get more information out of it, and in that case you can also drop GDP and population after creating the new feature using the feature selection method. Now we will implement it in our platform. So when you see, I have these features: order ID, table turnover time, kitchen staff count, meal period. We have a data for a particular food chain or a restaurant. Now order ID using domain knowledge, one can say, is not as relevant because it is randomly allocated. It is just an identifier. However, in some systems, the order ID may indirectly capture some information such as time of order or sequence of transaction. Customer who arrive early in the day may place different type of orders compared to late night customer. So you should always, before making prior assumptions, try to train the model or try to let machine learning model identify patterns that are not so obvious. Therefore, instead of immediately dropping, we should first evaluate whether they have any correlation with the target variable or not. Now we will explore some of the relationship and we'll see how we can use scatter plot, small multiple bar plot and box plot. Firstly, I will select the table turnover time, and it is a continuous variable. So we will create a scatter plot with all continuous features. So we can display the plots and we can see the order ID is having no correlation. The data points are scattered randomly. Then we have the table turnover time with itself has a perfect correlation because these are the same variable. Then we have table turnover time with kitchen staff count. So we can see when the staff count is higher, the table turnover time is less. So this is also how efficiency can be captured using two variables. The table turnover time has some relation with kitchen staff count. And then we have check amount in US dollars, that is our target variable, and table turnover time. So there is not a very strong correlation in this also. Now moving forward with small multiple bar plots. This is for categorical features. So let us go with meal period and we will create for all categorical features. You can also select if you want specifically for all input or output features, but here I am choosing all, so it will cover both input and output. So when I click on display plots, this is my meal period. And when we go into this, we can identify in the order type and meal period that dine-in is more common for dinner, lunch, but delivery is very less in breakfast, right? So dine-in does not change a lot, but delivery changes a lot. Dinner has very high chance of being a delivery order, while breakfast and lunch has lower chances. Then we have wine pairing, and this does not show a lot of correlation. So we can also move forward with our box plot. Box plot would be used for, we'll select a categorical option wine pairing, but we will select the continuous features as the second type, and we'll display the plots. So for continuous features, we can see order ID does not change a lot. There is very little correlation. That yes is slightly on the lower side, right? Then we have table turnover time, also not changing a lot. Kitchen staff count, almost exactly similar, and then check amount has a difference here. So wine pairing has higher check amount, the median is also higher, the distribution is on the higher side, which makes a lot of sense because people who are having wine or any kind of alcohol are paying more as compared to people who are only there for food. So this is how we can calculate the correlation, not calculate, but have a look at the correlation using the graphs in the software. And after that, you can select if you want to keep some features, drop some features. You can go to feature engineering, create features using feature interaction, and then come back and drop the features that you do not need. And you can also train the model, check for cross validation, then drop the features, again check what gives you a better performance. So this is how you can iteratively check what feature or what group of features gives you the best possible predictive accuracy as well as interpretation. Thank you.